A mole is a unit of number that is used in chemistry because atoms are so small that there are so many of them in even a grain of sand. Just like how a dozen of smoothie is 12 of that thing, a mole of something is 6.02 times 10 to the 23rd of that thing. This number is also given the name Avogadro's number. This is a big number to think about and also to calculate using our calculators. So let's have some practice. So the first question, calculate the following using definition of mole as a conversion factor. 1 mole equals 6.02 times 10 to the 23rd. So A, number of sulfur atoms in a 0.750 mole sulfur. So we already know what is given, 0.750 moles sulfur. And we also have the conversion factor of 1 mole equals 6.02 times 10 to the 23rd. So let's start off writing 0.750 mole sulfur. Then we would multiply it by 6.02 times 10 to the 23rd per mole. So now we can see that we can cancel out moles, and let's enter it into our calculator. And what did you guys get? We have 4.51 times 10 to the 23rd. And how many suffixes do we have? So 1, 2, 3. And this is the exact number, so we don't count the suffix here. So 1, 2, 3. So this is our answer. 4.52 times 10 to the 23rd. Question 1b. Number of carbon dioxide molecules in a 0.000100 mole CO2. How should we do this? Well, it looks like it's the same problem as A, just different numbers. So let's write this out. 0.000100 moles CO2 times the conversion factors of mole, which is 6.02 times 10 to the 23rd over 1 mole of CO2. So we would cross out moles and leaving us these numbers to enter. Times 6.02 times 10 to the 23rd. So it gave us 6.02 times 10 to the 19th. And here we have 3 sig figs. So 1, 2, 3. So it works out. And this is our answer, 6.02 times 10 to the 19. Alright, let's look at number 2. The antiperspirant. A. How many moles of aluminum are present in 1.5 moles of antiperspirant? Our given is 1.5 moles of antiperspirant. So we are looking for how many moles of aluminum are present. So we will start off writing our given 1.5 mole of antiperspirant times mole antiperspirant, So in this problem, since we don't have a coefficient, we will be using the subscript, which is 2. So it will be 2 mole aluminum. So now we can cross out mole of antiperspirant, and now we calculate 1.5 mole times 2. And what do we get? We get 3. And our suffix is only 168, since that is the lowest. When you write out 3 mole of aluminum. Problem 2b. How many moles of sulfate ions are present in 1.5 moles of antiperspirant? So our given again is 1.5 mole, and we're looking for how many moles of sulfate ions. So we would write out 1.5 mole of antiperspirant times 3 mole of sulfate over 1 mole of antiperspirant. Now, how did I get 3 moles? We get from our sulfate. And we're doing the subscript and not the coefficient number. So now we can cross out mole of antiperspirant. And now we would multiply 1.5 times 3. And it will be equals to 4.5 mole of sulfate. Moving on to problem 2c. How many moles of oxygen atoms are present in 1.5 mole of antiperspirant? So our given and then we're looking for how many moles of oxygen. So same steps from above, 1.5 mole of antiperspirant of Al to SO4, 3. Multiply that by the subscript, which is, we're looking for oxygen, so we're doing 4 times 3 equals 12, so that's going to be our mole of oxygen. So 12 mole of oxygen over 1 mole of antiperspirant. And we cross out the mole, leaving us 1.5 times 12 equals 18 mole of oxygen. And 266. The molar mass is defined as the mass in grams of 1 mole of a substance. To find the molar mass, add up the individual atomic mass of all the atoms in the compound. The atomic mass listed in the periodic table can be read with units of grams per mole. For example, hydrogen has a mass of 1.008 grams per mole. Problem number 3. We need to calculate the molar mass of each of the following. So for A, we need to find O2. So on our periodic table, we need to find oxygen. And we need to know the atomic mass number, which is 15.9994. And we can round that up to the 10th place. So that would give us 16.00. And since we have 2 oxygen, we would multiply that by 2. So that would give us 32 grams per mole. And that will be your answer. For the next one, B. And now we're trying to find a loop. For B, we need to find the antiperspirant molar mass. So now we need to find aluminum, which is 26.98. Let's write it out like this. 98. And then there's 2. So multiply it by 2. Next will be sulfur. And the atomic mass number is 32.066. And I'm going to round that to 32.7. And we will multiply it by 3. And now we need to know oxygen, which is 16. And we need 4 times 3, which is 12. So you multiply oxygen atomic mass number by 12. So let's calculate all this up. 26.98 times 2 will be 53.96. 32.07 times 3 is 96.21. And 16 times 12 is 192. And now you would add all this up. And what do we get? Is 34 to 17. And that'll be your grams per mole. Very easy. And let's box this one up too.
Once we have the molar mass, it can be used as a conversion factor. Since we know the equality between the mass grams of substance and the count mole, we can convert grams to moles and moles back into grams. This is important because instead of counting how many atoms we have, which is impossible with what we have in the normal laboratory, we can now weigh what we have and use the molar mass of compounds to know the amount of molecules we have. Number 4. Using the molar mass calculated in question 3, calculate the mass in grams for each of the following. 0.25 moles of O2 would weigh how much in grams? So our given is 0.25 moles of O2. So we will write out 0.25 moles of O2 times 32 grams of O2 because we multiplied the mass of oxygen twice because of subscript 2 all over 1 mole of O2, giving us 8.0 grams of O2 because there are 2 sig figs in 0.25. Letter B. So 0.000100 moles of Al2SO4 with subscript 3 would weigh how much in grams? So we use 0.00000 moles of Al2SO4 subscript 3 multiplied by 342.17 because that is the mass of Al2 and SO4 with subscript 3 multiplied together all over 1 mole. Giving us 0.0342 grams because there are 3 sig figs. Number 5. Now going in the opposite direction, we need to be able to calculate the moles of O2 if you weighed out 0.5 grams of O2. So we're going to use 0.5 grams of O2 because that is our given, multiplied by 1 mole over 32 grams of O2, so we can cancel out the grams, which gives us 0.02 moles of O2. B. Calculate the moles of Al2SO4 subscript 3 if you weighed out 355 grams of Al2SO4 subscript 3. So we're going to use the given 355 grams of Al2SO4 subscript 3 and we're going to multiply that by its mass, which is 342.17, which was found in the question 4. And we're going to which is going to be over moles being on top, which equals 1.04 moles of Al2SO4 subscript 3. If we think chemistry is like cooking, then the mole is a way for us to measure the ingredients, the chemicals, in the same way. A chemical equation is the recipe. A chemical equation contains the reactants on the left and products on the right. Chemical equations must be balanced. The amount of each element on the left must be equal to the right. Balancing equations is a trial and error process, and you just get better with practice. So let's practice. For number 6, we're going to balance each of the following equations by keeping an inventory of what is on the reactant side and what is on the product side. So on the reactant side, we have 4 for P and 2 for oxygen. And on the product side, we have 4 for P and 10 for oxygen. Since we have to equal it out on both sides, I'm going to multiply oxygen by 5, which gives us 10, which makes each side equal. So on oxygen, on the reactant side, I'm going to write 5. For letter B, on the reactant side, for Mg, it'll be 1. And for Ag, it'll also be 1. And for NO3, for NO3, it'll be 1. And on the product side, Mg is 1, Ag is 1, and NO3 is 2. Since we have to equal both sides, we're going to multiply Ag by 2 because NO3 is made into 6, so it has to be equal